Well, hello. And in this video, we're going to look at some past paper exam questions on the first part of the radiation topic at National 5 Physics, types and uses of radiation. So, let's crack on with the first question. Which row best describes alpha, beta and gamma radiation? Pause the video and see if you can figure out the answer. Okay, so what we need to understand is that an alpha particle is made up of 2 protons and 2 neutrons, effectively a helium nucleus. A beta particle occurs when a neutron inside of the nucleus of an atom decays and turns into a proton and an electron, and then the electron, which is the beta particle, is fired out of the nucleus. And a gamma ray is a photon of electromagnetic radiation. So alpha helium nucleus, beta electron from the nucleus, and gamma electromagnetic radiation. Answer B. Question number 2. Alpha radiation ionizes an atom. Which statement describes what's happened to the atom? Okay, so think about this and I'll tell you the answer in a second. Okay, so ionization occurs when an atom loses or gains an electron. Now, if the atom were to lose an electron, it would become positively charged. So the answer is C. Question 3. During ionization, an atom becomes a positive ion. Which of the following has been removed from the atom? Well, we just explained that in the last question. So it's B again, an electron. Number 4. A sample of tissue is irradiated using a radioactive source. A student makes the following statements. The equivalent dose received by the tissue is, and we've got to decide which of these statements is or are correct. So let's take them one at a time. Have a little look first and see if you can figure it out. Okay. So first of all, the equivalent dose received by the tissue is reduced by shielding the tissue with a lead screen. Well, that's obviously going to be correct because less radiation is going to reach the individual. Secondly, the equivalent dose received by the tissue is increased as the distance from the source to the tissue is increased. Well, that's clearly not correct because what's going to happen is the further you are from the radioactive source, the less of the radiation that's going to reach you. So increasing the distance would actually decrease the equivalent dose rather than increase. And thirdly, the equivalent dose received by the tissue is increased by increasing the time of exposure of the tissue to the radiation. Well, that is going to be true. The longer you're exposed, the greater the dose you're going to receive. So answers 1 and 3 are correct. So there's our answer E. Number 5. A paper mill uses a radioactive source in a system to monitor the thickness of paper. Here's a diagram. Radiation passes through the paper and is detected by the Geiger-Müller tube. The count rate is displayed on the counter as shown. The radioactive source has a half-life that allows the system to run continuously. A. State what happens to the count rate of the thickness of the paper, count rate if the thickness of the paper decreases, So, think about this. What's going to happen? Well, the radiation is having to pass through the paper. And some of the radiation will be absorbed by that paper as it passes through. The thicker the piece of paper, the more radiation that will be absorbed. Therefore, if the thickness of the paper decreases, more of the radiation is going to make it through. Therefore, the count rate is going to increase. Question 6. The nuclear reactor produces waste that emits nuclear radiation. State a use of nuclear radiation. So, we have to be aware of various uses of nuclear radiation so that we can answer a question like this. There are lots of different uses that we can mention. There are some in medicine and some in industry. For example, treating cancer in radiotherapy, medical investigations using radioactive tracers, sterilizing medical instruments, monitoring the thickness of materials like in the previous question we just looked at, used in smoke alarms as well, and checking for leaks or blockages in pipelines in a similar way to how tracers are used in medical investigations. And another valid use of nuclear radiation is in nuclear power, generating electricity. Question number 7. A technician wears a film badge to monitor exposure to radiation. The film badge contains a piece of photographic film behind windows of different materials. And here we can see a diagram of the film badge, and you can see that there are various windows made out of plastic, aluminium of different thicknesses, and lead. And there is also an open window which is exposed. Explain how this badge is used to determine the type of radiation the technician has been exposed to. So from this we need to understand that radiation will cause photographic film to turn dark. Now, different types of radiation can penetrate different windows of the badge. For example, alpha radiation could pass through the open window but would be absorbed by all of the other windows. So the only black area would be behind the open window. Beta radiation would probably pass somewhat through the plastic window and a little through the thin aluminium window, but not through the thicker aluminium window. And gamma would pass straight through all of the windows except for the lead window, and the lead window, being only 1 millimeter thick, will only slightly decrease the gamma radiation. So, by monitoring behind which windows have darkened, the type of radiation absorbed can be determined. That brings us to the end of this set of questions. So perhaps you'd like to go on and have a look at the second part of the radiation topic now, which is about problem solving, dissymmetry, activity, and half-life. In the meantime, goodbye for now.